Dear students, in this video you will learn about under excitation, over excitation and critical excitation of synchronous motor. First we will see under excitation of synchronous motor. Under excitation means the induced EMF is less than the supply voltage V. So, when the excitation is adjusted in such a way that the magnitude of induced EMF, so induced EMF here we are considering EB is less than the applied voltage V or supply voltage V. The excitation is called under excitation. Under excitation means the induced EMF is less than the applied voltage or supply voltage. Okay. So, due to under excitation, ER is increased and synchronous impedance ZS will be constant and current drawn from the supply will be increases. Current drawn from the supply is increases. According to the Ohm's law, we can write I is equal to V by R. So, where V is supply voltage, R is resistance. Here ZS is constant. So, V is increasing or ER is increasing in this case, then current flowing through these conductors will be increased. So, but ER is phase shift in such a way that the phasor IA also shifts. So, ER is in phase with the IR. So, once ER is phase shift, IA also will be phase shift. The angle between ER and IA is equal to theta here. So, where theta is represents the angle between ER and IA. So, here IA and cos pi component is constant. So, once if it is having in phase, then IA and cos pi is also will be constant. So, already we have seen the phasor diagram of excitation in previous video, under excitation and over excitation, those things. So, the power factor cos pi decreases, power factor cos pi decreases when the lagging nature. So, current flows compared to the motor, compared to the voltage, if it is a lag, so then power factor will be decreases. Okay. So, this is about under excitation. Now, we will move to the over excitation. The over excitation means the induced EMF in the synchronous motor is more than the supply voltage V. So, here we can see here the excitation of the field winding for which the induced EMF becomes greater than applied voltage VB, applied voltage V. So, EB is more than the V, then the excitation is called over excitation. So, due to increasing in the EB, ER is also increases in magnitude, but the phase of ER also changes. So, already we have seen this under excitation. So, ZS is constant, ER is increases, current will be increases. In similar concept, so here the phase angle will be constant, ZS is constant and IA is changes its phase. So, current flows in the armature winding is changes its phase, right. Now, IA increases to keep IA into cos pi constant, ER is also changes. So, in this case IA becomes leads with respect to V phase. So, since it is a over excitation condition, IA will be leading position, in under excitation IA will be in lagging position. In over excitation, synchronous motor works on leading power factor. Since IA is leads the supply voltage V phase, then power factor also will be in the case of leading position. So, power factor decreases as over excitation increases, but it becomes more and more leading in nature. Okay. So, now we will see critical excitation. So, in critical excitation, both induced EMF and supply voltage will be equal, almost equal. So, when the excitation is changes, power factor is changes. The excitation for which power factor of the motor is unity, cos pi is equal to unity, then the motor is running under critical excitation. So, we can also tell induced EMF in synchronous motor is equal to supply voltage, then the motor is running under critical excitation. Then I phase is in phase with V phase. Now, Ia cos pi must be constant, cos pi is equal to 1. So, both current and voltage both are in phase, the phase angle will be equal to 0, cos pi is equal to 1, right. So, in critical excitation the power factor value will be equal to 1, that is the highest value of the power factor. The maximum ends motor as draws minimum current from the supply for unity power factor condition. So, when the power factor is equal to 1, that is highest power factor, current drawn from the supply will be minimum. So, in critical excitation, current drawn from the supply will be less. So, critical excitation cos pi is equal to 1, current drawn from the motor is minimum compared to current drawn from the motor for various excitations. So, here we can observe in this table various type of excitations, what is the power factor, what is the relationship between induced EMF and supply voltage. For under excitation, first one is under excitation, the power factor is in lagging nature and induced EMF EB is less than the supply voltage. For over excitation, power factor will be in leading nature, then induced EMF EB is greater than supply voltage V. For critical excitation, so power factor will be equal to 1 or unity, induced EMF is equal to supply voltage V. Next one, for normal excitation, power factor will be in lagging nature, since inductive winding is inductive nature. So, power factor is in lagging nature, both induced EMF and supply voltage will be equal. Okay. So, this is the various excitations, under excitation, over excitation, critical excitation and normal excitations. Okay. So, this is also one of important topic for your exams. Sometimes they may ask you to explain excitations of synchronous motor or different types of synchronous, different types and different excitations of synchronous motors. Okay, right. So, in next video we will see about V curves and inverted V curves, synchronous condenser, disadvantages of low power factor. So, these topics we will see in next video. Thank you everyone.